All right. That's not our calendar. Actually, I don't even know if I did our calendar. I think it was a little lazy on getting the calendar put up today. So after the school ends, I'll definitely get that going. I don't think the microphone works very well when I walk away. I'm a little disappointed in that as I tested. I thought it would catch a lot more sound. So probably was a little too cheap with it. Spent $11 on it. But anyway, as I said before, top half of this page we're gonna have to have memorized. Oh, you know, and I did do this too. I wanted to go to this and actually look at our calendar, and I actually did do this. So I like this thing. I don't think we need to see my face, but here we are in class. Here's my board. We could do like a double do, double things going on in class here. I've done that before. Okay, so looking at the calendar, I put this thing up here. This was just for your benefit if we want to proceed on and do well, at least have a chance at doing so. I will show the unit circle I grabbed. I don't know if this one's as good, but what I do like about it is it kind of puts chapter 3 and 4 together. Here we see the sine, or that's the cosine curve that I have my cursor going over. The green one's the sine curve, then the other one's the tangent curve. So the relationship between the graph, input, output, and then the unit circle, moving around the unit circle. Now moving my cursor here to the unit circle. The only problem I have with this is, and I guess they can't really do it, but they don't put it in exact form. So I'm going to stop at 45. First of all, if I could, probably better if I'm looking here instead of up there. Boom. What's the now we should actually go through this, and actually this is going to be a big part of this chapter. Maybe not right away before break, but after. This chapter really has two parts, and today's a little different. Today we have some old chapter 1 examples coming up, but using our identities to try to get it memorized. After that, you have two parts. One is knowing your chapter 3 ratios. And that's what I'm going to kind of go through right now and go back over here. The other parts we're actually going to do on Thursday, start the process of, it's kind of like a game, it's simplifying. So we have trig expressions, and you're going to simplify them using that sheet in front of you. All right, my replacement and substitution is really all it is. But what I'm worried about is not knowing chapter 3. So I'm going to help you with that, and hopefully those that are in tune with and did their homework in chapter 3 will remember this. So what's sine of 30 degrees? Do you remember that from the very beginning? What's sine of 30 degrees? What do we always get for that? There's our there's no radical in it. I'll give you a hint. What is it? Not 1. That's sine of 90. What's sine of 30? Anyone? Nope. We got to flip it. That'll give you a hint. 1/2. And then lock it in. If you've done your homework a lot, you remember sine of 30 is a half. So then cosine of 30 is the other one. What's the other one that you always got with 30 or 60s in sine and cosine? Root. That's a root. Root 3/2. Just try to think of the picture of the triangle at this point. 1√3, 2. Sine is 1/2. Cosine is √3/2 for 30. So then what's sine of 60? Could sine of 60 be 1/2? Yes or no? No. So what is sine of 60? You just invert the relationship. So what's sine of 60? The other one. Root. Everyone say it. Come on, say it. √3/2. You say it, you actually activate your brain. This is what drives me nuts about teaching these days. Everyone just sits and looks around and doesn't even repeat what other people say, and then you don't activate yourself. Let's go. So sine of 60 is √3/2. What does cosine of 60 have to be? The other one, which we already said, which is what? 1/2, because you're just inverting what sides are what when you switch the angles. And hopefully you get those relationships there. So that's really the majority of the battle. Because then after that, you should be able to find tangent. And I'll show you how to find it today with one of our identities. And then you should be able to find the other 3 just by flipping, right? Just by knowing who the flip of each is, which we'll reiterate that today. Now let's go to 45. Oh, this disappointed me yesterday too, but what's sine of 45? You should have written this like a billion times if you did your homework. Square root of 2 over, I'm going to give you a little bit more. Not 1, darn it. That's bigger than 1 anyway. Square root of 2 over, anyone? 2. It's the √2/2 that we got a whole bunch of times. Sine of 45 is √2/2. What's cosine of 45? The same, root 2 over 2. So that should really be easy. So I stopped here. Fine. I don't have exact, but guess what root 2 over 2 is a decimal is? Right here. What's root 2 over 2 is a decimal? 0.707. And then when I go to 30, so I kind of like this more as I go along, as long as we think about the, man, I'm having a hard time stopping at 30 today. Yesterday was a lot better. Stop. 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 Oh my gosh. Believe me, I'm frustrating myself. Let me tick a little bit. Hey, look at this. Hey, I gotta stop. Okay, here we go. All right, sine of 30. Look at that. 0.5. You can probably barely see it in green. And then guess what 0.866 is? As you lock that in, then this is a more useful unit circle. That's root 3 over 2 as a decimal. Okay, and then as you move along, oh, I hope I do a better job than that last one. 60. Stop. I can't stop it. Man, I'm so shaky. I'm getting a little worried about myself in my old age. Boom. Cosine of 60 is a half. Sine of 60 is 0.866. We got to start locking these in. We got to stop drawing triangles. Now, really, this is going to happen after break, as I know what we're going to do coming up here, but it's worth the discussion. It really is. And then there, I think that's what we said. Sine of 90 is 1. You said sine of 30 is 1. Actually, sine of 90 is 1 because we have the coordinate 0, comma 1. So then when we go to the next quadrant, look at the cosine and sine. Sine is positive, cosine is negative. All right, just activating that. All students take calculus. And then the 120, I'm really annoying myself here too, not being able to stop. Oh, I can't do it today. I don't know, maybe too much coffee. Okay, yes, I was nailing it here. Okay, so sine of a 60 is root 3 over 2. Cosine of a 60 is 1 half again, but it's negative because it's in quadrant 2. All right, I don't like this one as much, but I do kind of like the idea of the signs and moving around here. And I do like that they have the graphs off to the side. It kind of puts 3 and 4 together, the last two chapters that we talked about. This is the one I really like. And, it's on you to kind of look at this stuff and do something. I was really trying to find something, and they do have things called flashcards on the internet. And a certain site really does flashcards a lot. I think it's called Quizlet. It's kind of looking at them, and they were fine and great. I didn't get the perfect one that I was looking for, and I kept searching and searching. Then I ended up with this site, and I absolutely love it now. And I'm stealing it and keeping it for the rest of my career. All right, in teaching this. Look at this. This is the whole chart. This is the whole kit and caboodle, as they say. All the quadrants, and you have this on your calendar. It's on Friday. And it really would be smart if you actually kind of went through this and tried to just get your mind in the right spot as far as where everything falls in here. Because what I just covered is sine of a 30. Well, there it is. Show 1 half. Yes, I knew that. You could quiz yourself. There's the flashcard. All right, there's okay, I thought it was a half. It is. Then cosine of a 30. Show, I think it's root 3 over 2. Bam. Now, I'm going to talk about one of our identities. You can look on your sheet right now. That tangent is actually an identity, sine over cosine. And I didn't teach that with the unit circle. I wanted you to get the triangles down. I wanted to get used to the ratios so that you remember them through doing valid homework, not invalid homework or whatever. So sine over cosine, you have to envision that's 1 half over root 3 over 2. And the 2's cancel. We're going to have to start figuring out fractions because there are going to come big in this chapter. Then that ends up being 1 over root 3. What's 1 over root 3, everybody? Or a few. That's the root 3 over 3. Okay, that's how we understand that. We can, use this chart. Okay, and then, okay, I don't want to see that anymore. Or if you close this and go back in, they're gone. And then you can start all over. And then jump into like quadrant 3, knowing that 210 degrees is in quadrant 3. 7 pi over 6. 6 pi over 6 plus another pi over 6. I'm in quadrant 3. That's a 30. Yet again, sine of a 30 is what? Hello? What sine of a 30, everybody? 1 over 2. But in quadrant 3, it is negative. And that's how you do this. What's cosine in quadrant 3? Positive or negative? Negative. So this is the greatest, all the flashcards in one spot. Takes care of all 4 quadrants, and then all you'd have to do is know how to do angles bigger or smaller than that. And then just hitting like 240, there's the switch. See, and now we finally get this relationship if we have not gotten it before. The difference from a 30 to a 60 is the sides that you're looking at switch from opposite and adjacent. So that's why these switch. That's why we should have these locked in from all the work that we've done. Now, let's think a tangent. Tangent's negative root 3 over 2 over negative a half. 2's cancel. It's negative root 3 over negative 1. There's your root 3 value for this. Okay? So I think a lot of things were going wrong here. I think a lot of people were using the calculator when they weren't supposed to be. And then there's many different things of why we don't have these locked in the way we should. All right, so after break, that's where we're really going to hit these. I just know the chapter. I was thinking, what are my problems with the chapter? A, we're going to have to memorize some of the formulas. B, chapter 3. If you didn't do well in chapter 3, you're going to have to get on it here. And I gave you something there that can actually help you if you actually use it. Okay? Now, so let's go to this, and let's make sure I'm at where I'm at. So the notes look junky. It's all fine. You'd be smart to go ahead and rewrite these down in your own set of notes, even though I gave you a piece of paper, because these are the ones you have to have memorized. Now you can use that piece of paper to kind of look at them, so hopefully it sinks in. But you're gonna have these memorized. And I'm not asking a lot here. I mean, hey, I'm actually giving you another quiz, like I felt like I gave on the last graphing quiz. And quite honestly, it went well for very many, and still it did not for some others. And I don't know what I can do about that at this point. I almost gave you the quiz the day before, we did the quiz. So it's just a matter of memorization of that and all that other stuff. But there's the quiz. Look, those will be blank, and you have to fill them in. You are getting what the quiz is right in front of you. Okay. And actually, you should see that there's no problem with these first ones because we already know this. We already should, but this is the things that are continually to stumble people. Some people still don't know from chapter 1 that sine and cosecant are reciprocals of each other. They can't make that connection. We got to get there, or else this is going to be another disaster. So cosecant is equal to 1 over sine. Sure, that means sine is equal to 1 over cosecant. These are called reciprocal identities because they're the flip identities. They're the 1 over identities. That's what reciprocal means. We should already know cosine and secant are reciprocals of each other, and of course cotan and tan. So those should be, if I pick 3 of those 6, that should be 3 easy points. You miss those points, it's on you. It is 100% on you. Next thing, maybe a new one. I know they have it in chapter 1 and 2 in the book, but I've over the years tried to just get the most one approach. Sometimes I show 2 approaches to things, students get them all jacked up. And I knew we were going to end up in chapter 5 with identities. So I felt like this is the time. Tangent is definitely sine over cosine. Right? So that's an identity that tan equals that. And here's proof of it. Okay, please answer the question. What trig function represents y over r? What trig function represents y over r? Sine. We should all know that. Everybody in the room should say that. If you don't know that, there is a major problem. What's cosine of theta? What letter over what letter? Or what's dang it! What's x over r, which I just said the answer? Cosine. Okay, now notice what happens with the r's, and you better get good with this. Those r's do cancel. They're both in the denominator. And then this becomes y over 1 over x over 1, which is just y over x. Who's y over x, everybody? Everyone say it. Tangents. Okay? So that's a proof of that. Not a proof like just going through the process of why that is true. So what do you think cotangent is, everyone? Cosine over sine. It's just the flip, so it's another. So what I would say in this section is put these in terms of sine or cosine. That's probably what I said instead of quotient identities. Do be aware of what it means to fill out the reciprocal identities. Cotan of theta equals, you must write 1 over tan. Cotan doesn't equal tan. That's another thing that people do on the quiz, and I'm marking you wrong. The reciprocal identities mean write it as, what is it 1 over? This equals 1 over what? You have to write 1 over. All right? Simple, simple, simple. Now, this is why you want to write these even though you have them in front of you on that cheating sheets. So again, that cheat sheet is like that unit circle that I gave you in chapter 3. If you just stared at that and didn't really let your brain think about where the angles were, you caused your own demise on the next test or quiz. So I think everyone knows the Pythagorean theorem, right? Pythagorean theorem is a squared plus b squared equals c squared. So this is a simple mind progression. This is the way I try to teach, to play it into your minds to make this easy for you. We'll see if that happens. All right. But then what we did is we had a coordinate plane, and we put these triangles in a coordinate plane. So therefore, you had coordinates, and those coordinates were x comma y. So we made the triangle x first, then y, and then we came back to the origin. We called that r for radius. All right. And then you ended up with a unit circle that has a radius. So now I just changed, not a big deal, right? X squared plus y squared equals r squared, all right? With our new triangle with x, y, and r as the side measures. Here's where the majority of you will pick this up right away. How easy it is to derive the formulas in terms of trig. Please answer my question. Whatever you do to one side, do the other. So I'm going to really break this one down. You do what you want. It's your notes. I'm going to break this down mathematically, syntaxically, what exactly goes on here when I decide to divide both sides by r squared. By the way, on the left side, division is distributive. If I divided the left side by r squared, then I would have to divide both x squared and y squared by r squared. All right, I got this hidden here because I have something else behind that, and I'm going to break this down completely. The next thing is, and then notice it is this triangle that I'm looking at here. And I'm pretending I have an angle in quadrant 2, just pretending. I'm going to rewrite this as x over r squared, because that is true. When x squared over r squared is the thing, then you could just treat it as the whole fraction squared. By the way, what's r squared over r squared, everybody? 1. So we got a 1 on the right side. So that we'll just take care of that. Now looking at that triangle, sorry for my messiness here. What is x over r for theta for this triangle? What is x over r? What trig function is that? It's cosine. So the way you would write that is x over r is equal to the cosine of theta because of first chapter. Sir kicks or ticks. What's y over r, everybody? Sine of theta. And then and actually I should have collected your assignment that I gave you on the test. I fell apart on that yesterday, and I'm just going to leave it alone today. I'll wait till we get to some normalcy in here when we're actually coming back every day. The rule is I'm going to collect your homework daily because math doesn't work when you wait to do your homework. It just doesn't. And that's what a lot of people don't understand. Or they're just flat out not doing their homework and they won't. And I can't do anything about that. All right. But when you don't keep up daily, then things start to snowball and go out of control. So we are going to start collecting that. That is supposed to be done. That beginning stuff that I was talking about with the chart up here and knowing sine of a 30 is a half. That's the stuff you should have went over in your head with that sheet that I gave you. But on that sheet, this is why you should know this notation means this. And you kind of had to go backwards on that, and I've talked about that. This is just a mathematical notation where they don't like writing it cosine of theta then squared. They like to get rid of the parentheses and make it a simpler format. Okay, so that's what I was getting with here. On your worksheet, you were asked cosine squared of pi over 3 plus sine squared of pi over 3. What you were supposed to do is do sine of pi over 3, get the answer, then square it. And we've talked about that before. So you might want to revisit that worksheet, make sure you get that done. Today's only Tuesday, right? Yes, it feels like I said good, have a good weekend to my third period. They were looking at me like I was nuts. And then I went through the horror in my mind that it was only Tuesday and not Friday. Anyway, there we go. There's one of them. Sine squared plus cosine squared equals 1. All right. Next one. Well, I don't have to divide by r squared. What else could I divide by? Someone yesterday said z squared. Why would you divide by z squared? What else might you divide by? Not r squared, but anyone? X squared or y squared. And I forgot which one I divided by next. I did y squared. I didn't want that to appear. Okay, I did want to get rid of that though. Okay, so y squared. What if you divided both sides? This is why I don't think you have to go any further. You don't have to go through all that process. All you have to figure out is, first of all, everyone, what's y squared over y squared? 1. All you have to know is what's x over y. Oh, careful. It's cotangent. All right, so cotangent squared. What's r over y? It's the flip of sine. Cosecant. So this one is, can't get rid of that x. I think my pen is intermittently working and not working as usual. All right, so this one is cotangent squared plus 1 equals cosecant squared. And I can't help you if you're blown away knowing x over y is cotangent at this point. That's chapter 1. R over y at this point is cosecant. This is why everything builds on each other, and we're making the same mistakes over and over again if we're not learning this stuff and getting it solidified. Okay, then the last one, what are we going to divide by? X squared. And then all we have to know is, first of all, what's x squared over x squared? What's y over x, everyone? Tangent, and what's r over x? It's actually secant. It's the reverse of cosine. I heard someone say, whisper a cosine. Okay, then that last one, I didn't erase the third one, or the second one, I mean. And there's the last two. So real quick, I'm making you write the Pythagorean identities, real quick, just write x squared plus y squared equals r squared, and then divide by all three and just get yourself organized what's what. You notice on this, I always like to give you little tricks. Co, no co. The no co's go together, the co's go together, besides sine and cosine. But you have a lot of stuff in your mind that, like, you're trying to memorize. So that's why I like the x squared plus y squared equals r squared. And then just divide by 1. I mean, heck, this is what I would do. I go like this. Okay, fine. All right, the Pythagorean identities. All right, my pen. Great. Thanks, pen. X squared plus y squared. This is all I would do if you really get what I'm doing. Okay, I divide by r squared. X over r is cosine. Y over r sine equals 1. Simple. Okay, I'm done with that one. Now I'm going to divide by x squared. X squared over x squared is 1. Y over x is tan. R over x is secant. Okay, I'm done with that one. Now I'm going to divide by y squared. Y over I is 1. X over y is cotangent. R over x is, I'm sorry, x over y is cotangent. Wait, did I do that right? And then r over y is cosecant. Sorry, I was going too fast there, but you get the point, and I think the majority of you would be able to handle doing that. All right, super fast. Because it really isn't that hard to derive those. Really is not. Okay, where'd my notes go? All right, and then the last but not least, that's my little work over here. And then I'm going to show those crappy graphs up at the top that came out of the book, and then I jacked them all up with my own writing. Even odd identities, functions that are even or odd. Well, first of all, I hope you remember, but you probably don't. It's one of those forgettable things. I get it. Not being judgmental. That cosine is even and sine is odd. Here, I guess I'll show the graphs. There's cosine. Remember this? That's my sound for you probably I haven't done it that much this year, but for reflections or symmetry. Okay, this is symmetric with respect to the y-axis. That is an attribute of an even function. But another attribute is that this is true. Cosine of negative theta is equal to cosine of positive theta. What? And actually, this could come from, and we can analyze this with all students take calculus, right? Which is kind of something that really helps in chapter 3 as well. So what they're saying is cosine of negative 30, that should equal cosine of positive 30. That's what it's saying. That's just putting an angle measure in its place for this to really analyze this and see if this is true. And it is. And I should have asked you what's cosine of 30. And hopefully you would say, well, sine of a 30 is a half. So cosine of 30 should be root 3 over 2, the other one that I've written a million times. How come the cosine of negative 30 is still root 3 over 2? Because you're in quadrant 4. A, S, T, C. What's the C stand for in quadrant 4, everybody? cosine. And what does that mean about cosine in quadrant 4? It's positive, and there's the reason. It's the same root 3. Instead, you go down 1. So the down one's the y value. It has nothing to do with cosine. So this is true. So that tends to be true then, seen at one example. So we can just use ASTC to see these properties. Oh, by the way, who's related to cosine? We're going to write this for the 1 billionth time that secant is related to cosine reciprocally. So therefore, it's dealing with the same fraction but flipping, so this would be the same. 2 over root 3 was 2 over root 3, if we were doing secant of 30 and secant of negative 30. All the other ones are odd. Let me give you a real quick, ugly picture of sine, the two bowls. They're going across the origin. Origin is odd. Real quick on tangent. Remember, tangent goes through 0, 0. So let's mess that up between tan and cotan. Okay, but actually cotan's odd as well if I took a picture of it and put it up there. So we do have odd origin or origin symmetry. So what does that mean about sine of negative theta? It is not equal to sine of theta. It is equal to the opposites of the sine of theta. And that's the test algebraically for odd functions. That's why these are called even odd identities, because that's what it's stating there. Real quick, if we turn this into sine, I don't want to really jack this up and don't want to rewrite it. We should see that these are not equal. Sine of a 30 is a half. Sine of a negative 30 is a negative half. They're opposites of each other. So the only way that you could make these equal is if you snap the negative on this one on the outside. All right, and that's exactly what I wrote over there. Who, yet again, is related reciprocally to sine cosecant. So writing your notes is also a value, because at this point, if we're not writing notes and we're not doing our homework, there's a lot of not doing there. And that's why we don't know what we're supposed to know at this point. And then last but not least, tangent. You can look at tan of 30 and tan of negative 30. Tan of 30 is 1 over root 3. Tan of negative 30 is negative 1 over root 3. They're opposites of each other. So that's why tan of negative theta can be said to be equal to the opposite of tan of theta. Not the same. And then, of course, cotan follows, because they're dealing with the same ratios. Oh, I get a negative there. And then put cotan of theta there. Okay? So these are the ones you will have a quiz on, and basically you can count the quiz as this. One more time. Here's your quiz. No complaining. You'd have to fill those in. Any or all of them. There's your quiz. Fill in the blanks. All right? So you're basically given a quiz there. All right, and then moving on, we're going to have to be used to, and this is more, this will start happening Thursday. This is what our Thursday is. That's why this chapter is so, it's weird. You got really two separate, completely different components. They're all using the formulas, but they're using them two completely different ways. And hopefully by the end of it, at least you have an appreciation that they exist. You're not going to walk around and in the summer be able to sprout these back out. I will say this, if you go to calculus, which many of you I know will, every calculus book, front cover and back cover, has a list of identities. They have like geometric identities and blah, blah, blah. And then they have trigonometric identities. Watch, I guarantee it. Like what we're covering right now will be a whole huge section in the calculus book, moving forward. But really, this is not a big deal. Look at the very first one that I showed you for the trig functions. The trig Pythagorean identities. Sine squared plus cosine squared equals 1. You got to get used to this, that we could subtract cosine squared from both sides, and now that's what sine squared equals. And you're going to find out on Thursday or Friday for you guys that that's what's going to happen. You're going to see this, and we want to simplify it. We want to make it smaller. So you're going to change 1 minus cosine squared to sine squared because they're equal. That's all it is a replacement game. That's what's going to happen with this. All right, and I could decide to subtract sine squared, and it's just a different format of the same formula, just subtracting the same thing from both sides. This is often a kick in the stomach for the students. They often mess this up. Cosine squared minus 1 then? No, that's not equal to sine squared. That's equal to the opposite. Think about this above here, and I multiply both sides by a negative. It's real simple math, all right, how this turns into this, all right? So just make sure you're aware of that. This is a big one that's missed by students. They often say it's sine squared, not negative sine squared. One thing about this is wild. You're going to see this in an expression exactly like this. The very next thing you can do is replace that with this. What? Okay, well, look at this formula up here. Oh, I blacked them out. Oh, I didn't black that one out. You'll have to write those down too. But subtract cotangent squared from both sides. That's what 1 equals. So when you are simplifying geometric expressions, I'm sorry, trigonometric expressions, that is going to happen. I've lost myself here. There we go. Boom. That will be you replacing this with this because you have the knowledge of what that trig identity is. Okay, and then you'll find out those that do really well with this will memorize those top ones. But then also you're good at puzzle like solving. It's kind of like a puzzle to try to simplify these trig expressions. That's like the rubric. This is like the hieroglyphics. What does hieroglyphics do? Or what is hieroglyphics? Is that Egyptian? What's the thing that the Rosetta Stone? Doesn't the Rosetta Stone Greek and cuneiform? No, what is that? What is the? Does anyone know? Come on, I like history. Is it Egyptian? Is it hieroglyphics or is it cuneiform? Yeah, okay, but what is the Rosetta Stone translate? You know, no one knows. I thought it was Greek too. So, oh, who cares, right? I thought someone would know. I forgot. I wish I knew. All right, here we go. Now, with all that being said, we get these silly questions today. Now, I want you to do this a specific way. This is actually a chapter 1 question. You've already had this, and you actually had it in chapter 2 as well. You've already done this. This is the basis of coordinate trig, dealing with a coordinate plane. Okay? So they give you a piece of information. They say tan of theta equals negative 5/3. Right off the bat, what is 5? What letter is that? Y. Did you hear him? What is 3? X. What did we do in chapter 1? We immediately found what's the third letter? R. By what theorem? Pythagorean theorem. And then we filled in all 6 trig functions. And you perfectly can do that. But I think the smarter thing to do is actually use our new identities. And it does the same thing. Maybe a little bit more work, but then what you're doing is you're activating your brain and writing your formulas down and getting them locked in your brain that have to be memorized anyway. So tan of theta equals this, and you're in quadrant 2. Make sure you remember that. Don't lose that piece of information. So this is what I mean. Off to the left, this is my chapter 1 work. I'm not doing that. Right? I'm not doing the what we just verbalized. I'm going to go ahead and make myself memorize these formulas. Okay. So the one with tangent is 1 plus tangent squared equals secant squared. When I write this over and over again, it'll eventually sink in my brain. And then, not really what your worksheet that was due today, because it's a little different question, but knowing how to replace that. So tan of theta is negative 5/3. Tan of theta of the angle equals the ratio negative 5/3. And tan squared means I square that ratio. You don't care? You're already packing up shop? Okay. Then you square it. Not good. And then I'll put this equal to secant squared because I lost that. Now, what you should do is change 1 to 9/9. Okay, so 1 plus, square this, square this. This should not be getting a calculator. Square 5 and square 9. Square a negative, you get a positive. And then what you end up with is, really only need one example of this because this is what all the homework is today. And I really want you to use every single time the Pythagorean identity that is what's given in the question. Okay, and then you go ahead and square root both sides. Luckily, square root of 34 doesn't simplify. Square root of 9 is 3. Now look at the information that you have now from beginning to end. And I'll go ahead and erase this. Secant of theta, therefore, is root 34. And I made this the negatives on the 3 because you're in quadrant 2, and this is x, and that is y. So really, this negative 5/3 is 5 over negative 3 because of that information. Y, x, r. And then you see x again as negative 3. And then you're able to answer any of these questions. Well, you already found secant. Right there. And then how do you find sine? Sine is y, 5 over root 34 r. All right, so using a Pythagorean identity to get that. And then one more quick thing, they get a little jerky here. What's the cotan of not theta? Cotan of negative theta. Wait a minute. Cotan of negative theta is not cosine. This is the way I remember this too. Only cosine does it not change. Cosine of a negative theta equals cosine theta, and its brother or sister. So this is actually negative cotan of whatever theta is. Cotan of theta is the flip of that, but then I got to take the opposite of it. Right? So I just use another identity there. All right, so ran a little short. As you leave, I'm probably going to do the last example that we did in the other class, and you can just walk out and just watch a silly teacher talking to the computer screen. We are not doing this like chapter 1. We are going to do this using our Pythagorean identity so that we get these memorized. By the way, don't forget, sir kicks or ticks, so cut toe. So sine of theta equals 2/3, and theta's in quadrant 2. All right? So the very first thing I will do is plug in 2/3 for sine. Did you have a question? Oh, okay. So plugging in 2/3 for sine, squared theta, and we're going to square it. Actually, I'm going to show this work right here. This is going to be 4/9, and I'm going to subtract 4/9 from both sides because I know what I have written next. So I'm going to make this 9/9. Okay, so 2/3 is 4/9. Subtract that from both sides. Then square roots, and then I have my x, y, and r that I need. I already have y up here. I already have actually r here and here. Now I found what x is. And now I'm able to find all the trig functions through chapter 1. Sir kicks or ticks and the flips. Okay? And then you can look at those and see my rationalizations there. Okay? All right, and that's really all you got to do. But use the identities so that you get them memorized. All right? Now stop sharing.